All right, welcome to Class 7 of our CSE 104. And we got a lot to cover here in the next couple of weeks to try to finish this, or else we have to go to Class CSE 105 and 106 and finish it. Okay, we're dealing with the question right now, why did God use a flood? Why not just have all the bad people die? I get asked this question surprisingly frequently, why make Noah go to all that work to build this big boat and destroy the whole world? Couldn't God just as easily say, okay, everybody die, except Noah, you're okay? Interesting question. Why use a flood? Well, some points to ponder. I don't know the answer, by the way. I just give you my opinions on this. The flood left evidence. A miracle would not. That's the thing about miracles. You have no way to prove that they actually happened. It's just, you tell them it did, and then that's it. Okay. Secondly, the effects of the flood are still here to remind us. This would be a corollary to number one. The flood left evidence, but this reminds us of the judgment. And I think if we had a proper scriptural perspective on the world, you could look at fossils and see judgment of God. I mean, when you see a fossil saber tooth, one guy told me this looked like his mother-in-law. Jeff, you might want to consider that one. Fossils, this represents death and suffering, God hates sin. Fossils represent the hatred that God has toward man's sin. And I think what's happened, Satan is using this type of thing to, he's got people's minds twisted in where they see fossils as evidence for evolution. Satan uses everything he can. He doesn't have anything original. So this reminds us of God's judgment. Thirdly, it gave them a preparation time. People could see this ark going up every day. Walk by, hear the hammer pounding the nails, and say, man, I better get right with God. So that's my take on it. The Bible says in 2 Peter chapter 3 and verse number 20, which sometime were disobedient, when once the long suffering of God waited in the days of Noah, while the ark was a preparing, wherein few, that is 8 souls, were saved by water. So 1 Peter chapter 3 tells us that the long suffering of God was evidenced here. While the ark was being prepared, people could see. And it's demonstrated the long suffering of God. Okay, next question. Is the sun shrinking? In the early days of my seminar, I used to share something. One of the evidences for a young Earth, or a young universe at least, was the idea that the sun is shrinking. Here's the graph showing the recorded measurements of the sun in the last 160 or 70 years. The data shows that, yes, the sun is shrinking. This is from the Royal Greenwich Observatory. Now, this chart and this concept of the sun shrinking takes a lot of flack from the evolutionists. They will say, well, the sun is oscillating. It shrinks for a while and then it expands for a while. This, I think if you look at the graph, you can see, yes, that's true. The sun does shrink and expand and shrink and expand. The top number is the horizontal diameter of the sun. The bottom number is the vertical. That would be North Pole to South Pole of the sun. Because the sun, because it is spinning, is slightly bulged like the Earth is, slightly bulged. The equatorial distance is a little greater than the polar distance. So the observation is, hey, the sun is shrinking. The overall works out to be an average of about 5 feet per hour in the time it's been observed and recorded. Okay? There are a couple of problems with this. I will have to say, I'll give it a qualified yes, I believe the sun is shrinking. Okay? And I think it is still evidence that the universe is young. However, I don't use this in my seminar as in part one, as one of the evidences the Earth is young, because the jury's still out on what's causing the sun to burn. There are basically two different theories of why does the sun burn. One theory is it's just simply a ball of fire, gas burning, and gravitational collapse keeps the pressure up, which keeps the heat up. It's just so much gravity, so heavy. The pressure is enough to keep it ignited and keep it burning, or whatever. Of course, with no oxygen up there, the sun's not burning by burning up oxygen, like oxidation like we have here on Earth. The other theory is that the sun is a nuclear reactor. If the sun is burning by nuclear fusion, then it could burn for billions and billions of years with that much fuel. You figure a nuclear submarine can take a golf ball-sized piece of fuel and sail around for a couple of years, before it burns it up. So if the sun is burning nuclear, though, if it's a nuclear burning, the problem is it should be producing what are called neutrinos. Neutrinos come from nuclear fusion, and they apparently go right through anything. They go all the way through the Earth. The way they tested to see if the sun is burning by neutrinos, or the sun is burning by fusion and sending off neutrinos. When these neutrinos go through dry cleaning fluid, I forget the chemical name for it now, but when they go through dry cleaning fluid, they will produce argon gas. Just one of the byproducts. Neutrino goes through and produces argon. So they took this gigantic tank or built a gigantic tank in the bottom of a mine, an abandoned mine they weren't going to use anymore in, I think, Utah or something, real deep in the mountains. They figured, okay, this is a good place to test this out, because if we're deep enough in this mine, it'll be isolated or insulated from any surface neutrinos that are being produced by nuclear reactors and stuff like that. And only from the solar neutrinos. The theory was they thought this should somehow isolate it. After several years of watching, there was an article in 1974, I think it was Scientific American, I've got the article somewhere, saying that they've been watching for several years and there's almost no argon gas being produced in this tank. So we're not sure how the sun is burning, was kind of how it ended. But so far there is no proof the sun is burning by nuclear fusion. It appears from the chart that the sun is indeed shrinking, and this does put some kind of time limit to the age of the sun, because obviously it used to be bigger. The bigger problem with this, besides just the simple diameter of the sun increasing, eventually it would touch the Earth. But that would be a long time, at 93 million miles. At 5 feet per hour, that would be the diameter changing, not the radius. So the distance between the sun and the Earth, you'd have to figure the radius as far as the distance there. Even that would be a problem. 5 feet per hour would be a problem. Go back a few billion years, it would become a serious problem. Get your calculator and do the work, and you'll find out it wouldn't take too many billion years, and the sun would be touching the Earth. The other problem, though, is if you go backwards in time and add mass to the sun is burning and losing about 5 million tons every second. That's what it's burning up. Okay. As it's burning and losing this mass, the gravity that the sun has to pull on the Earth to keep us in orbit depends upon the sun's mass. If the sun were more massive, the gravity would be stronger. So if you went backwards in time and increased the sun's mass, that would increase the gravity, which would suck Earth in. So it really is a stretch to say that the sun has been burning for billions of years, and the Earth has all this time been at just the right distance for life to evolve. That's one of many stretches they have to make in their imagination. Okay, next, what about carbon dating? Does carbon dating work? Okay, first, let me explain how carbon dating works, and then I'll explain the problems with it. The Earth is surrounded by an atmosphere, and people argue about the number, but it's about 100 miles thick. Well, 100 miles on this 8,000 mile scale, 1,000 miles would be 1/8 of this, or about this far. So 100 miles would be about that far, not much, okay? It's a very thin layer of air around the Earth, but 100 miles is a lot. Meteors come in and get burned up before they hit the surface. The vast majority of them burn up in the atmosphere, and you see what we call a shooting star. Actually, it's not a shooting star, but who cares? That's another story. Anyway, Earth's atmosphere, about the highest part we can breathe is maybe 4 or 5 miles. 5 miles is a stretch. You go up 5 miles, you're on top of Mount Everest. Really tough to breathe up there. The air is so thin. 100 miles, it's real thin by the time you get out there. So, solar radiation is striking the atmosphere continually. Earth's atmosphere is mostly nitrogen, 78%, which is an inert gas, won't burn, won't support combustion, and 21% oxygen, 0.06% carbon dioxide. Now, some books, if you look this up in the textbooks, some will say it's 0.03%. And some will say the oxygen is 20.9. There are various numbers here, but this is a reasonable average, okay? 0.0000765% is radioactive carbon-14, which mixes with normal carbon dioxide. See, carbon dioxide is made from carbon and oxygen. 2 oxygen molecules and 1 carbon. They get together and make CO2. Carbon dioxide doesn't seem to care if it's got the radioactive carbon molecule or the regular carbon molecule. Normally, carbon is number 12. Carbon-14 has been produced by sunlight striking the atmosphere, changing nitrogen into carbon-14. It doesn't care, the molecule doesn't seem to care if it's radioactive carbon or regular carbon. Now, surprisingly, there is a guy who works at a nuclear plant in Savannah, Georgia. I spoke at a church there. He said, Brother Hovind, I'll pay $1,000 to anybody who can prove carbon-14 even exists. He said, I don't think it even exists. There's no such thing as carbon-14. I mean, I haven't gotten that far in the study, but I think he's wrong, but I couldn't prove it, okay? There are an awful lot of creationists and evolutionists who would argue, oh yeah, carbon-14 is a very real thing. You just need to keep in mind there is a possibility that there is no such thing. Okay, this guy's had the offer out for a long time. Insects that are trapped in amber occasionally have air bubbles with them. The air bubbles found in amber indicate that the Earth's oxygen level was much higher than it is today. Today it's 21%. It used to be about 35% in the past, sometime in the past. The creationist says this is just before the flood came. I think that's probably correct. Okay, here you got radiation from the sun striking the Earth's atmosphere, forming carbon-14. High-speed bombardment of cosmic rays in the upper atmosphere produce fast-moving neutrons. These neutrons collide with atmospheric nitrogen, producing carbon-14. To refresh your memory in chemistry, or to teach you if you never learned it, this is called the periodic table. Notice right there is atomic number 6. If it's atomic number 6, that means it has 6 protons and 6 neutrons, which gives it a weight of 12. They only weigh the protons and neutrons. Electrons are considered 0. They're not worth anything. They're too light. So I'll blow it up for you here. The atomic weight of carbon is 12.03. The atomic weight of nitrogen is 14.01. Its atomic number in the upper left-hand corner is 7. Its atomic weight would be the 7 neutrons plus the 7 protons, total of 14, plus the 0.01 for good measure thrown in there. Okay, who cares? Sunlight strikes nitrogen, changes it to carbon-14. So it's knocking off, I forget if it's the protons or the neutrons, it's knocking 2 things off. So it's now considered carbon. I guess it must be knocking off. Let me back up here. I have to look it up and see exactly how it does it. The theory is that it knocks off either the protons or the neutrons. I don't remember. Anyway, it changes it to carbon-14. Used to be nitrogen. Now it's carbon. But it's a special kind of carbon. It's not carbon-12. It's carbon-14. Okay. This carbon-14 is a very unstable atom, and it begins to decay like uranium. Decays, falls apart, breaks up. Called radioactive decay. Uranium does the same thing. And you can hear it with the Geiger counter. You walk by uranium, you see the guys on the movie, you know, with click, 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 click. They're hearing the uranium as the particles fly off from the decay of the atom. Carbon-14 decays, and the half-life has been estimated through pretty intensive testing in the lab, and I wouldn't argue with them too much about this. The half-life is 5,730 years. It's considered the half-life of carbon-14, which means if you had a pile of carbon-14, half of it would change back to nitrogen in 5,730 years. And I'm surprised there's even an argument here. I've seen different textbooks. Some say carbon-14, when it decays, it turns to carbon-12. Other textbooks say, oh no, it turns to nitrogen. Other people say it doesn't even exist. So I guess I can't answer the question clearly, though I've read several things on it, and there seems to be a conflict. Most people say it changes back to nitrogen. That seems to be the standard theory. Who cares? Anyway, during photosynthesis, plants breathe in CO2 and make it part of their body. There's the photosynthesis formula there. 6 carbon dioxide atoms plus 6 water or molecules, 6 plus 6 water molecules is going to give, in the presence of sunlight and chlorophyll, 1 sugar molecule. C6H12O6 is sugar. That's a simple sugar, plus 6 oxygen molecules. So plants, as they grow, they take in carbon dioxide and water from the roots and magically change it into sugar and oxygen. The oxygen is released back into the air. The plant doesn't want that. The sugar it takes, and it uses that to make plant cells and leaves and roots and branches and everything else. That's its fuel in the form of sap, which is why they make maple syrup, which tastes so good. It's a very simple, good-tasting sugar, basically. Now, sucrose that you buy at the store, the white sugar that you put on your cereal, that is C12H22O12. That is called a compound sugar. and it's much harder for your body to digest. Honey is a simple sugar like this. Sucrose is a compound sugar. And so when you eat regular sugar, it gives you energy. However, it takes energy in order to break it apart so you can use it. So honey will give you much more energy per spoonful, much more than regular sugar will. And again, who cares? Okay. So plants are breathing in carbon dioxide. It ends up as part of the sugar molecule, which ends up in the plant cells. Animals come along and eat the plants and make it part of their tissue. During your lifetime, you have probably either eaten animals or you've eaten plants. How many have done that before? Everybody. Good. That's about all there is, right? That's the choice. You want to eat a plant or you want to eat an animal that ate a plant. Either way, this carbon-14 from the plants ends up in the food chain. You're going to eat the plant directly by eating a salad or something, or an apple or an orange or whatever, or you're going to eat the animal that ate the plant. You eat the hamburger, but what did the bull eat? He ate the plants to get there, okay? So this C14 goes right through the food chain and it ends up everywhere. The theory goes that the ratio of radioactive carbon-12 to normal, or radioactive carbon-14 to normal carbon-12 in the atmosphere would be the same ratio found in living plants and animals. Now that is just a theory. Nobody's ever proven this. So how much carbon-14 does Nick Pretzhook have in him right now? Well, probably the same that's in the air. If the air is 0.0000765%, probably the plants are the same ratio, because after all, they're breathing the air. And probably the animals are the same ratio, and probably Nick is the same ratio because he has been eating plants and eating animals all of his life. So this is just an assumption. Nobody's proven this, but it sounds reasonable, and I'm not arguing it. I'm just pointing out this is an assumption, that living plants and animals will have the same percentage in them as the air contains. So since the sunlight is making this stuff all the time in the air, and it's decaying, falling apart, the amount in the air at the time the creature dies would have to be known to determine how long it's been dead. Here's how it works. When the plant or animal dies, it stops taking in new C14. So as soon as it dies, it's going to start to go out of balance with the air. The air is going to always have, in theory, the same amount, 0.0000765%. But if the animal's been dead for a while, it'll have less carbon-14 because it's been decaying like uranium, it's falling apart. So Willard Libby got the brilliant idea back in 1950 or 47 to use carbon dating to test the age of objects. He said, it'll be very simple. Since the amount in the air never changes, mistake number one, as I'll show you in a minute, and animals are eating this stuff, and plants are breathing this stuff, and animals are eating the plants, we can tell how long the object's been dead just by checking at how much C14 it has. So when it dies, C14 begins to decay. Half of it will be gone in 5,730 years. So if you check the air and find out it has 1,000 molecules of C14, and the fossil has 500 molecules, so hey, it's been dead 5,730 years. Sounds real good. It doesn't work. I'll show you. In theory, the way carbon dating is supposed to work, it never goes to zero. It goes to a half, then it goes to half of a half, which is a fourth. Then it goes to half of a half of a half, which is an eighth. And then it goes to a 16th, and then a 32nd, and then not much. Okay? Since it's a random event, this molecule, it just all of a sudden it breaks apart. It's like a box of hand grenades. You never know which one's going to go off. But there's random average is that half of them will explode and decay in 5,730 years. So if you waited another 5,730 years, you'd only have a fourth, and then an eighth, and then a 16th. Nobody's ever proven that's true either, but it is reasonable. So it's going to continue to decay. After 5 half-lives, there is so little left, you can't measure it. So 5 half-lives of, say, roughly 6,000 years each would be how long? 30,000 years. About the max you could measure with carbon dating, if it worked, was 30, 40, or 50,000 years. That'd be the most you could ever measure. So if somebody tells you, we know the Earth is millions of years old because of carbon dating, red flags ought to go up and say, beep, this guy doesn't have a clue what he's talking about. Okay? Because even if it worked, the max would be, say, 30 to 50,000 years. It'd be a good quiz question. You can put down there, Jessica. What's the maximum carbon dating would work for? Okay, so they compare the amount of C14 in the object being dated with the amount currently in the atmosphere, and they estimate how long it's been dead. Sounds good, but here are the assumptions that mess up everything. Has the amount of C14 in the atmosphere always been the same? How could you possibly know that? You can check the atmosphere today and find out how much C14 is in it. No question. They can measure it real precisely. How much C14 was in the atmosphere 1,000 years ago? I don't know. Anybody here know? Actually, Ron Cooper, check R. Cooper at archae.org. He has an interesting article that he's written on showing all the measurements that show carbon-14 has not reached equilibrium yet. Here's an analogy that'll help you understand it. If I asked you to fill a barrel with water, if I said, here's a barrel, here's your job, here's a hose, fill the barrel with water. And you don't realize it, but I've drilled holes in the other side of the barrel. So while you're filling the barrel, it's leaking. As you get up a little higher, it starts leaking out 2 holes. Get up higher, it leaks out 3 holes. At some point, if my holes are big enough and if your hose is small enough, you're going to reach a stage called equilibrium. You will never fill the barrel past that point. This is sort of like your checkbook, you know. You keep putting it in and it keeps leaking out. It's bank accounts. Eventually reach some kind of stage called equilibrium, right? If it's leaking out faster than you're putting it in, then you eventually will have a problem, right? If you're putting it in faster than it's leaking out, eventually you'll be a millionaire. Between those two extremes is equilibrium, okay? It's going to be put in and taken out at the same time. Earth's atmosphere is like a bank account. It's 100 miles thick. Sun shines on it while the Earth is spinning. So the sun shines equally on all parts of the Earth, in theory, you know, all the time. During the summer, of course, the North Pole gets it 24 hours a day, but during the winter it gets it 0, and so it balances out. Every square inch of the Earth should get sunlight at some time. This is producing carbon-14, which is also decaying. As soon as you make it, within 5,000 years, half of those molecules will be gone. 5,730 years. Some people argue and say, oh, no, it's 5,790 years. Oh, some people say, no, it's 5620. You'll find a lot of different numbers if you research it. Okay, you'll be surprised how many numbers are out there for the estimates of what is the half-life of C14. It doesn't matter to me. They all range about 6,000 or less. Okay, so here we have a problem. Suppose we took a brand new Earth. Here I am, I'm going to pretend like I'm God. Poof, there's the Earth. Stick it out, get it going around the sun. Right away, it starts making C14 in the atmosphere. The sunlight is producing this stuff all over the atmosphere while it shines on it. At the same time, it'd be starting to decay. So basically, I'm starting to fill the barrel. Could I tell how old the Earth is by determining how long it would take to fill the barrel to equilibrium point? There's complicated formulas to do that, but if I asked you to figure out how long would it take to fill a barrel with water, I give you a 1-inch hose and I've drilled 1/4-inch holes up the side. Here's the diameter of the barrel, here's the height of the barrel. Yeah, with a little complex mathematics, you could calculate when you would reach equilibrium. Right? Same thing with the atmosphere. You could calculate the surface of the Earth, the sunlight, etc., and determine within about 30,000 years the Earth's atmosphere would equalize. That's what they did, and they said, oh, about 30,000 years the Earth would equalize, or reach this point of equilibrium. I don't remember where I got that 30,000 number. I think it was from ICR. I know I talked to Kurt Wise about it at Bryan College, and he said, yes, 30,000 is the number. He graduated from Harvard University under Stephen Gould, and even though Kurt Wise is a creationist, Stephen Gould was his teacher. I should look up Just go make a note for me to find the reference for where I got that 30,000 year number, and I'll try to add it to the bottom of the screen here. I've never had anybody argue with me on that. Even evolutionists will say, yeah, that's right, 30,000, but I don't know exactly who figured it out or when. My understanding is Willard Libby, or one of the guys during that time frame, calculated the Earth would reach equilibrium in 30,000 years. So Willard Libby says, okay, we know the Earth is millions of years old. Mistake number one. So we can ignore the equilibrium problem. Mistake number two. It has now been discovered the Earth's atmosphere has still not reached equilibrium. So if there's more C14 now than there was 1,000 years ago, and we dig up a fossil from 1,000 years ago and carbon date it, what's going to happen? It's going to look like it's been dead longer than it really has been. Just simply because they had less C14 than we do now. Does that make sense? It's going to appear to have already aged. It started with less. And that's exactly what happens, okay? So the Earth's atmosphere has still not reached equilibrium. This is a rather complex proof that the Earth is not yet 30,000 years old, which I could have told them just from reading this book. Okay, it's about 6,000 years old. Which puts another crimp in the get along of those who want to say the gap theory, or the day-age theory. Well, hold on, there's not enough. Earth hasn't reached equilibrium in carbon-14. Here's an oversimplification of how it works. If an animal is not even dead, it's still alive, it should give you about 16 clicks on your Geiger counter per minute, per gram of carbon. It's actually a little more complicated than that, but this will help you understand the analogy. If you're only getting 8 clicks per minute, you would say, oh, I should be getting 16, I'm only getting 8. This only has half the carbon it's supposed to have, therefore it is 5,730 years old. What if you're only getting 4 clicks per minute? It's gone through 2 half-lives. It's 11,460 years old. If you're getting 2 clicks per minute, you'd say, oh, wow, that thing is 17,000 years old. What would you do if you're checking your fossil and you're getting 2.5 clicks per minute? You simply find the place on the curve where 2.5 would be, read straight down. Very simple. If you're getting only 1 click per minute, it's 22,000 years old. Well, here are the problems. If you walked into a room and found a candle burning on a table, and I said, Daniel, when was it lit? And you said, I don't know, Brother Hovind, it was burning when I got here. Like that burn barrel stinking up the room right now, right? Out there burning. Let's do what's called empirical science. Let's measure the height of the candle. This we can do very accurately. We're going to measure the candle and say it's 7 inches tall. Okay? When was it lit? Who knows? How long was it burning before we got there? Don't know? Don't know. Well, about the only other empirical thing we can do. The word empirical means something you can measure or test or weigh. This is real science, not theoretical science, I believe or I think. I mean real empirical science. Science would probably divide into excuse me, at least those 2 categories. Empirical, things you can measure and weigh and test, and theoretical science. Okay. Let's also measure the rate of burn. Suppose it's burning 1 inch per hour. Now who can tell me when it was lit? Still can't. Why not?
Don't know how tall it was.
Good. We'd have to make an assumption. How tall was it? What other assumption do we have to make? Has it always burned at the same rate? We watched it burn 1 inch an hour. Does that mean it's always burned 1 inch an hour? How would we know that? Bottom's thicker, it burns slower. Suppose there's more oxygen in the room. There's a lot of factors could influence the burning of the candle. Okay? You dig up a fossil in the dirt. This is exactly like your burning candle. The amount of C14 can be measured very accurately. The rate of decay can be determined very accurately. But that's it. Would you know how much C14 was in the air when that animal was alive? No. Would you know that the decay rate has always been the same? No. You don't know how much C14 it had in it when it was alive, and you don't know that the rate has always been the same. Just like the candle, you don't know the initial height, and you don't know that the decay rate or burn rate's always been the same. If the Bible is correct, I should say since the Bible is correct, the earth, according to the scriptures, had a canopy of water overhead. Either water or ice or water vapor, I don't know. There's clouds up there right now, and they're water vapor. Some people have argued there was no canopy. We've been through all that before. The canopy of water would block UV light. It'll allow long-wave radiation in, but it won't let short-wave radiation in. The color spectrum that we see will go right through it. The UV light would not go through water. Interesting. That would probably prevent the formation of C14. So suppose we've got an animal that's living on the earth before the flood comes. He's living under a protective canopy of water. There is very little, if any, C14 in the atmosphere. He dies, gets buried in the flood. We dig up the fossil and carbon date it. We're going to assume it started at 16. When we measure it, how much is actually going to be in that critter? Very close to 0, right? Since there's very close to 0 C14 in that critter, we're going to say, wow, let's look at the graph here. Close to 0, that thing is 30,000 years old. Right? Is it? No. It's 4,400 years old. But we assume it started at 16. And there's the problem. You don't know it started at 16. The canopy would have messed everything. The flood would have really messed up everything. Changed everything around. Let me give you a few examples of how it doesn't work, and then we'll take a little break here. Living mollusk shells were carbon dated at 2,300 years old. Now, this is back in 1963. And some of the scoffers will say, well, carbon dating has gotten better since then. Well, 1971. Freshly killed seal carbon dated at 1,300 years old. So apparently it is still not working, is it? I mean, if they just killed it, hello, it's not 1,300 years old, right? 1984. It's not getting any better. Shells from living snails, carbon dated at 27,000 years old. Now the skeptics will say, yeah, but we know why that date is wrong, because these snails live in a creek that's in an area with a lot of limestone, and the limestone contains a lot of carbon, and it washes into the water, and the snails are drinking this water and making it part of their tissue, so we know that date's wrong, and we know why. Okay, I understand. Then, do you know the dates that are right? You know this one's wrong because you know where this snail lived. What if you carbon dated this saber-toothed tiger? Do you know where it lived? You know what kind of water it was drinking? How could you possibly know any dates are correct? When you find an awful lot of them are wrong, how could you determine which ones are right? See the problem you got here? 1975, one part of a mammoth was 29,000 years old, another part's 44,000. Now, I just ordered today Geological Survey paper 862 from the government printing office. It costs $1.75 for the paper and $5 for shipping. But we'll get it here in a few days, because one person wrote me a nasty letter and said, Hovind, don't you realize that these two dates were from two different animals? Because I did not read the actual paper yet. I will get it here in a few days. This quote is from Institute for Creation Research's book, Henry Morse, That Their Words May Be Used Against Them. And it's from, I believe this, I forget who exactly said it. So this is a second-hand quote. I didn't read the paper myself, but I'm getting it for the skeptics out there. I will look at the paper myself, and I will stop using this if it's proven to be incorrect. But this book, That Their Words May Be Used Against Them, I believe is where this came from, showed that the dates are from the same animal. In the same paper, this fellow said one part of Dima, the frozen mammoth, was 40,000 years old. Another part is 26,000. And the wood next to it was 9,000. And the skeptics will argue, well, yeah, that's because certain parts of this mammoth were contaminated because, you know, water was flowing through there and it washed out some of the C14, so it gave an older age. Okay? Then how do you know the other fossils that you dig up you have the right age for? See what I mean? You got a problem either way. 1949, when they first started doing carbon dating, Harold Anthony wrote an article in Natural History and showed how the lower leg of a mammoth is 15,000 years old, but the skin was 21,000. And the skeptics will say, oh yeah, but we've gotten better at it. I think we've shown they have not gotten better at it. 2 Colorado Creek mammoths, this Colorado Creek, Alaska, carbon dated 22,000 and 16,000. Which one's right? These mammoths are side by side. Living penguins dated about 8,000 years old. 11 human skeletons, the earliest known human remains in the Western Hemisphere, have been dated by accelerator mass spectrometer. All 11 dated at about 5,000 radiocarbon years or less. Oldest skeletons we have, less than 5,000 years old. Why would that be? There was a flood. This is not carbon dating. This is accelerator mass spectrometer dating. There are several different ways they can try to date things to see how long they've been dead. Material from dinosaur bones were dated at 34,000 years old. Normally, if you took a dinosaur bone in and said, would you please carbon date this, they would say, no, we won't do that because it's too old. It's off the chart. The chart only goes back 50,000, and this is 70 million, so it won't work. Well, how do you know it's 70 million? Try it anyway, please. Would you please carbon date it anyway for me? They just won't do it. Okay? Russian scientists, however you pronounce their names here, carbon dated dinosaur bones at under 30,000 years old. Hugh Miller had this done, Columbus, Ohio. This guy had dinosaur bones dated at under 20,000 years old, about 20,000 years old, because he did not tell them they were dinosaur bones. If he would have told them what they were, guess what number they would have come back with? 70 million, probably. All right, let's take a quick break. Come back, talk a little more about carbon dating and then potassium argon dating when we get back. Okay, let's continue now a little bit more on carbon dating. Let me read this quote to you, a very interesting story here. A geologist at the Berkeley Geochronology Center, Carl Swisher, used the most advanced techniques to date human fossils. Last spring, he was reevaluating Homo erectus skulls found in Java in the 1930s by testing the sediment found with them. By the way, let me make a comment here. Homo erectus, we covered on videotape number 2 about the big caveman, has been renamed several times. It was first called Java man, then it was called Pithecanthropus erectus, and then now it's called Homo erectus. In any case, it's baloney. Okay, it's not a missing link at all. But Dubose went to Java, which is part of Indonesia, down by Vietnam, looking for missing links. I mean, that's why he went. Okay, so this guy's not a unbiased observer. He gets there. He finds a little piece of a skull cap from an orangutan, I believe it was, or an ape of some kind. He found 3 human teeth. They were not together. And he found a human thigh bone, I think it was a year later, and 50 feet away. He concluded, wow, ape's skull cap, human thigh bone. This is an ape that could walk, half human, half ape. He didn't tell everybody that he also found 2 normal human skulls in the same area. He hid those under his bed, under the boards, under his floor. Kind of like Telltale Heart, Edgar Allan Poe, you know. And because he knew if people found out he spent all his time over there digging in the dirt to find a dead ape's skull, everybody would think, why are you spending all your time digging in the dirt to find the dead ape skull? You know, if you're going to spend your time digging in the dirt, you want people to think you're doing it for a good reason. You don't want people to realize how dumb you are for spending all your time digging in the dirt to find this bone. All right. So, and back to the story here. A hominid species assumed to be an ancestor of Homo sapien, which is baloney, erectus was thought to have vanished some 250,000 years ago. Again, baloney. Even though he used 2 different dating methods, Swisher kept making the same startling find. The bones were 53,000 years at most, and possibly no more than 27,000 years. A stretch of time contemporaneous with modern humans. I would like to point out, Your Honor, that this is not an exact science, okay? If you get an error of 96%, is this beyond all reasonable doubt? I'd say this raises incredible doubts, okay? How do you know either one of the dates are right? How do you know it's not 50 years old? I wouldn't trust any of the dating methods any farther than I could throw them. So here he's getting 96% error. But even then, this is not what they were looking for. They were looking for 250,000, weren't they? They didn't get close. Here's what you ought to consider about carbon dating. When you date a sample of known age, like the snails or the penguins or something like that, you know how old it is. It's still alive. It doesn't work. If you date a sample of unknown age, it is assumed to work. That's silly. As elements decay, they produce helium. One of the byproducts of radioactive decay, as the molecule explodes, it sends off alpha particles or beta particles and helium. Uranium way down in the ground is decaying. This helium gets trapped. Slowly finds a little crack and works. Helium floats, you know, like we have helium gas to fill balloons with. This helium migrates around through the rocks if it can, okay, and eventually it'll collect inside a cave. If it's got a roof where it can't get through very quickly, you might go into some caves and you're walking along the cave and you happen to get into a high part, the ceiling may be full of helium if there's no circulation in the room to stir it up. So you're breathing and you start talking real funny, you better get out of there because you are no longer in oxygen. You probably have about 2 or 3 breaths and you're going to faint. You're now in helium. The miners used to bring canaries down with them when they went into the mines because the canary is very sensitive to the atmosphere and it would drop over dead if you were in an area that didn't have oxygen. Because sometimes in mines, they're digging out the coal is, you know, decaying or whatever and producing different gases that are poisonous. But, or they're just explosive, like methane or something. And they're down in this cave and this, you know, air gets trapped in these caves. I went into a big coal mine up in Birmingham, west of Birmingham. They took me down into the mine at 3 in the morning. It didn't matter. It was dark down there in the daytime too. But they had this giant fan, the biggest fan I've ever seen in my life. It was probably bigger around than this room is tall. I would say it was a 16-foot fan blade. They got this thing mounted to a big diesel engine, and it's cranking like crazy, blowing air, and it's got a big tunnel built over it down into the ground, which goes down to the coal mine. At the other end of the coal mine, 2 miles away, there's another big hole to suck air in. And this fan has a backup system, I mean all kinds of emergency bells and whistles, and if the motor goes down, another motor kicks on. That fan constantly is blowing air out, sucking air through the mine to make sure they don't get a methane buildup. And you go down in the mine and you can feel this breeze blowing all the time. I mean, this fan is incredible. We went up, you could hear this thing 6 blocks away, you know. They turned the fan on. Man, it was incredible. Anyway, who cares? This helium eventually is going to get out of the rocks, if it can, and get into the atmosphere. So the theory says the Earth is billions of years old, and there's been how many earthquakes during these billions of years? Oh, wow, there's been a lot of them, you know. As the Earth cracks and moves around and shakes, this helium is going to find a way out. It's going to get into the atmosphere. Helium, being a light gas, is going to float up real high in the atmosphere. Very little of it is able to actually escape to space, but some of it can. You know, helium can get out there to the edge, and the molecule just bounces off and drifts off, gone forever. After calculating all factors, how much helium is able to escape from the atmosphere? How much is being produced? There's only enough helium in the atmosphere for less than 2 million years of Earth's existence. So if the Earth has been here for 4.6 billion years, why isn't there more helium? Helium is an extremely rare gas in the atmosphere. Why isn't there a lot of helium up there? Yes, sir?
Can you expound on why very little is able to escape into space?
There's several factors that influence, like a pan of water just sitting there eventually evaporates. The molecules on the surface are wiggling around, and they might get enough energy to jump up and then fall back down. And evaporation, as you add more energy, they can bounce around faster. If you really add energy, like a flame underneath, and get it boiling, now the molecules are moving around like crazy, and they can fly off into space, and you can boil away a pot of water much faster than you can just watch it evaporate. The Earth's atmosphere has energy being added from the sun. This energy is moving the molecules around. Some of them get enough energy to bounce off and be lost. But you figure a molecule, you know, 200 miles from the Earth, what's the nearest body attracting it? The Earth. chances of it falling back in are very great. Whereas a molecule of water bouncing off of a pan of water gets up into the atmosphere, and now it has air molecules to move it around. So the chances of it finding the water again are slim because it's in an atmosphere. However, with Earth, you're dealing with right next to the air is space. Nothing. So it still has gravity pulling it back. You'd probably have to contact guys like ICR to get all the technical details on how they calculate how much helium can escape. Okay. Some of it can, but it's very different. It's the same principle, but it's very different numbers you'd have to use in your equation than a pan of water with molecules escaping because there's no air. One of the many factors that keeps the water from just simply flying off is air pressure. There's many factors, gravity, surface tension, et cetera, et cetera. So Jonathan Sarfati, who writes a lot for Creation magazine and for creation material, and does a great job, by the way, in 1998 wrote this article, said there's only enough helium in the atmosphere for 2 million years worth. So this is, again, one of the more complex evidences that this Earth is not billions of years old. ICR has a great book on the real technical aspects of carbon dating if you want to get the go down long, go down deep, stay down long, come up dry kind of arguments. This would be a good one. I've got it in my office there. Showing why the old numbers that they get from dating methods simply are not reliable. We all know from what we covered in video number 4, which would have been about CSE 103 early on maybe, that fossils are really dated by the strata they come from, and strata are dated from the fossils they contain. We won't review all that now, but there's quite a few quotes here about that. Geologic column is how strata or fossils are dated. Actually, no fossils are dated with carbon dating. They can only date things that contain carbon. And by the time a bone turns into a fossil, there's no longer any carbon in it because it's all been replaced by the minerals in the ground. They can only date things like charcoal or things that still have carbon in them. Wood could be carbon dated in theory. Okay? It's all based on circular reasoning. Here's an interesting quote here. In the last 2 years, an absolute date has been obtained for the Gandong beds above the Trinil beds. It has the very interesting value of 300,000 years, plus or minus 300,000 years. Well, exactly how old is that layer? Somewhere between 0 and 600,000. I vote for 4,400. That's my vote. Okay. Moon rocks were brought back in 1969, given to many different laboratories to be dated. One rock, called the Genesis rock, specimen 10017, was divided into 6 pieces and dated many times. The ages ranged from 2.5 billion to 4.6 billion. Well, Your Honor, if you're getting nearly 100% error from the same rock, how do you know any of them are right? James Dawson has a website. He was Chief of Engineering and Operations. His website, jpdawson.com. Here's his phone number, address, etc. He worked on lunar samples, including the Genesis rock. When I called him back in January 69, or 99, I said, Mr. Dawson, how old is the moon? He said, I don't know. We got numbers of 10,000 to several billion from the same rock. But after dating all the moon samples, they, of course, came up with a date and said, well, the moon is 3.5 billion years old, because at the time, that's what they were teaching the age of the Earth was, 3.5 billion. Marvin Lubenow, in this book, Bones of Contention, have you read that one yet, Jeff? This is in the pile to be read, right? That's an excellent, excellent book. Okay.
I saw a magazine today that had the same title on it.
There are probably 100 books out there with that same title. Because that's a phrase. I have a bone of contention. It means I have an argument with you about something. There's bones of contention, and then we have another little magazine called magazine format booklet called Bone of Contention. You probably ran into this making the catalog, Daniel. Slight difference in title. Who cares? Anyway. He used an interesting article Marvin Lubenow has about how they change the dates whenever they need to. And it deals with potassium-argon dating. Potassium-40 is another radioactive element. It has a much longer half-life. Remember, the carbon-14 half-life is 5,730 years. This book says 5,770. Like I said, you're going to get numbers all over the scale, but somewhere around less than 6,000. Potassium-40 has a half-life of 1.3 billion years. Well, anybody with half a brain ought to be asking themselves the question, how do they know that that's the half-life? Who watched it for 1.3 billion years anyway? Obviously, nobody did. Same with carbon. Nobody watched it for 5,000 years either. What they do, they will take a sample of the radioactive element in the laboratory, surround it by Geiger counters or photographic film or something that will record when a particle breaks up, sends off this little alpha particle or beta particle, and it'll make an impression on the X-ray film or the Geiger counter or a click or something. Through very careful testing, they can actually determine how many molecules are decaying in, say, a 3-day period. Let's suppose we take a sample of carbon-14, we put it in a machine, and we surround it by instruments that will measure how many clicks it's giving off. We know this contains 10 million molecules. 3 days later, we have counted 817 of them that decayed. So we get our calculator, 817 decayed in 3 days out of 10 billion, and they work up a formula to get the half-life. It's generally done on a 2 or 3 day sampling. I won't argue with them. They're probably right. The half-lives are probably correct. I'm not arguing with them. But I think people do need to understand, it does sound a little fishy to test it for 3 days and come up with a 1.3 billion year number. That just sounds a little fishy to the average person, I think, of average intelligence. But I won't argue with them. I'll tell you, yes, your number is probably correct. However, you still have the assumptions. Has this decay rate always been the same? How much was in it when it died? The interesting thing about potassium, when it decays, it produces argon, which is a gas they use for welding. We have a tank of argon to go with our welder. You turn it on when you're welding and it does something to the weld. I don't remember what now. I don't care. But argon gas, I forget what else it's used for. It's like 1% of the atmosphere is argon, or less than 1%. So it's a pretty small amount. Potassium produces argon. And since argon is a gas, the theory goes, wow, when a volcano erupts and the lava is flowing out, since it's a hot lava, it's going to drive all the gas off. So there's a lot of potassium in lava, and since there's no argon, mistake number one, if we found a lava flow, we could tell how long it's been hardened by how much argon is in it now compared to how much potassium is in it now. Because it should start producing argon, and half the potassium is going to decay every 1.3 billion years. So this is called potassium-argon dating. They're checking to see how much potassium is in it and how much argon is in it. They're assuming when the eruption took place, it reset the clock to 0. There should be no argon. Mistake number one, as we'll see in a minute. Okay? It has been proven over and over and over and over, potassium-argon dating does not work. However, they still rely on it. Many scientists rely on this. When a volcano erupts, it throws out a layer of ash all over the countryside. If you find a fossil under that layer of ash, in the mud or rocks or whatever, you would assume this animal died before the volcano erupted. Right? Then more layers of mud get on top of this ash, and more animals die and get buried in the mud. And then another volcano erupts, or the same volcano erupts again. New layer of ash over the countryside. If you're digging straight down through these layers of ash, if you find a layer of ash, which is called, by the way, an event horizon, this is a major event. Volcano blew up. Okay? Anything between those two layers of ash should be between the ages of that ash. So they actually date the layers of ash with potassium-argon dating, and then estimate the age of the fossils between the two dates. Like this picture here from National Geographic, 85. They show 1.8. Well, the top one's 1.4. What they're saying is here is that layer of ash dated at 1.4 million years old. The next one down dated at 1.8 million years old. If you find an animal in between, what number are you going to give it? Somewhere between those two numbers, right? That's how it's done. So the ash layers are dated, and that is called an event horizon. And then any fossils under that are older, any fossils over that have to be younger. It sounds really good. Doesn't work, but it sounds really good, okay? And very convincing to the average freshman college student. I'm sure he swallows this up whole. KBS tough. By the way, tough is a name for ash. An ash layer is called a tuff layer, okay? This is named after K. Berensmeyer, okay? K. Berensmeyer, KBS, I forget what the S stands for, K. Berensmeyer or something. The KBS tuff was named after her because she discovered this layer of ash digging in Africa someplace apparently and said, wow, let's have it dated. And since she's the one who had it dated, it got named after her. I mean, if you spend all your time digging in the dirt and all you find is an old ash flow, you got to be famous for something, I suppose. So, K. Berensmeyer they named this tuff after her. Everybody dated this KBS tuff using potassium argon dating at 212 to 230 million years old. This is from Nature magazine, April 18, 1970. Many people would check the KBS tuff. They'd get a sample of it, and they try to get an uncontaminated sample. They find the layer, dig way back into the hillside, use rubber gloves and the whole thing, and try to get a sample and don't let any air touch it, and seal it up, go to the laboratory, and date it. And everybody was having a contest who can get the closest to the exact date of this KBS tuff. Because if we know the age of that ash layer, then anything below that's older, anything above that is younger. Sounds good. Arguments raged about how old is the KBS tuff. Different scientists published papers and said, oh, no, that thing is 219 million years old. Somebody else said, no, it's 229 million years old. I checked it, and my way is better than your way. Okay? And they argued back and forth in the Nature publishing articles. They got to publish about something, I suppose. And the arguments, though, were within this age range, 212 to 230 million. Everybody's happy. This number gets published in numerous journals, and everybody accepts it. Until 1972. Richard Leakey came along and found a skull, a perfectly normal human skull, under the KBS tuff. Well, this is going to mess things up royal, isn't it? Because here we've been teaching everybody that man didn't evolve till 3 million years ago. How do you get a modern human skeleton under a layer of ash that's 212 million years old? Well, they'll try to find ways to make this happen. One way is they'll say, well, maybe the person was buried there. He fell into a crack and, got covered up, and it looks like he's under that layer, but he really wasn't. You just found him under the layer, but he was buried there. He was put in later. I mean, people dig graves now. Dig a hole, put the person down there, right? Okay. KNMER stands for, when fossils are found, they give them a number. K is for Kenya. I forget what the other ones are for, but it's easy to look up in a book somewhere. Each of these numbers and letters has a significance for where it was found and who found it, I think. Their name is encoded in here somehow. So we find skull number 1470, normal human skull, but it's in rock that is too old. So what are you going to do with this? First, they try to discredit it and say, oh, no, it was not really there. It was put there later. So after everybody digs around, and the guy who's digging up these bones, of course, has to very carefully document everything he does to make sure people believe in him, because somebody's going to try to prove him wrong. And finally, everybody agrees, okay, he's right. This was not put in the ground. I mean, all the layers above it are undisturbed. This guy wasn't buried here. He lived here. So now you can come to two choices. Aliens visited the planet 200 million years ago, which is honestly what some people came up with. A bunch of folks said, well, this proves aliens came here. The other choice is to say the layer's not really that old. Right? So that's what they decided to do. Well, that layer's not that old. Even though it had already been dated a bunch of times, and everybody agreed it's over 200 million years old. Because they found this skull, they're going to check it again. Suppose they had never found that skull. Nobody would have checked it again, would they? And everybody would have accepted that age. And somewhere else, somebody would find a fossil under that, and he would date it by the KBS tuff at 240 million. So this entire geologic column is all a house of cards. Everybody's date is based on somebody else's date, which is based on somebody else's date, and the whole thing's a bunch of baloney. All right? But this is how it's been constructed through the last 150 years. By all of this stuff of putting these dates together. Okay. They dated the skull at 2.9 million years old. Still got a problem. So they took 10 different samples of the KBS stuff. Everybody who wanted to be famous said, I'm going to go prove the date of that. KBS is, everybody was wrong. We're going to get it right. Because I got to publish an article so that I can keep my government grant. Basically is what it boils down to. So now they got 0.5 million to 2.64 million. Well, I'd like to point out two things. Number one, that is still way down from 200 million, right? Number two, they never would have redated this thing if they had not found that skull. Right? Can you see how many, is your mind racing thinking, wondering how many dates are in there that they haven't been able to, they've published them and everybody's believed them, but they haven't been able to verify them.
9,000% error factor.
That's a 9,000% error factor. But even with the two dates they did get, 0.5 to 2.6, that's a 500% error. Even the new dates are no good, right? And they call this science? That's not science, that's fairy tale stuff. So, of course, everybody that had ever dated the KBS stuff before, that used to be hero, wow, he got it right, he was 218 million, you know, now all of a sudden he's a villain. Why didn't he catch that back then? And they've got a whole list of excuses. They can reach in and grab which one of why they got the wrong date. Well, it was contaminated, he didn't have accurate equipment, he didn't know what he's doing, he didn't graduate from the right university, or whatever. You know, I'm sure they got a whole list of excuses they'll pull out. Back in 1770, George Buffon was one of the guys who began teaching the Earth is older than 6,000. See, when Darwin's theory came out in 1859, Darwin was in the middle of an era that had already been teaching for nearly 100 years that the Bible isn't right on the age of the Earth. People already believed in evolution way before Darwin, but they didn't know how it happened. Darwin just simply gave them a mechanism. Here's how it worked, folks. Oh, wow, thank you, Darwin. You explained it to us. Okay? That's why Darwin is treated like God. Back in 1770, George Buffon said the Earth is 70,000 years old. In 1905, in Newsweek magazine has the article about it, the official age of the Earth was 2 billion years old. If you get some old textbooks from the early 1900s and look up the age of the Earth, it'll say the Earth is 2 billion years old. When they went to the moon, 1969, there's an article from the newspaper, Minneapolis Tribune, August 25th, 1969. The article said, study shows moon rock to be 3.5 billion years old. The official age of the Earth and the moon was 3.5 billion when I was in high school. There it is. Look at the circle on the far right. It was possible to estimate the age of these extracted samples in terms of the extent to which radioactive potassium-40 had decayed into stable argon. It is largely through measurement of the extent of this slow decay process that scientists are able to determine how long it has been since a rock was last heated by volcanic activity or other processes. You see how it's done? So they said the rock is 3.5 billion years old. That's the last time the moon was heated and the argon gas escaped. It reset the clock. Yeah, right. Today, students are taught it is 4.6 billion. I saw a book recently that said it's 4.65 billion. Guess what? They're trying to add a little more, aren't they? Well, I calculated the Earth is getting older at the rate of 21 million years per year for the last 220 years. That's 40 years per minute. We're aging rapidly, folks. Okay? Here's some things to consider about carbon dating. Wild dates are often obtained. Dates that don't fit the evolutionary theory are rejected and not published. Correct dates that get published match the geologic column. So why did you date it to begin with? You already think you know how old it was based on your geologic column. Why are you doing it with carbon? Why check it with carbon dating? It's based on the assumption that the original content of the sample is known. It's based on the assumption the decay rate never changes, based on the assumption the sample has not been contaminated. I would like to point out, just by way of passing here, all these decays. Potassium decays to argon. Uranium decays to lead. All of the decays are elements going downhill on the periodic table, not uphill. So if the Big Bang made hydrogen, how do you move uphill to get to uranium so that it can start decaying back down? Something just to consider. Basalt, which would be from a volcano, lava flow, from Mount Etna in Sicily in 122 BC when it erupted. When they took samples of this basalt and potassium argon dated it, they said it's 250,000 years old. Well, now hold it. We know it's only 2,000 years old. Why would it give a potassium argon date of 250,000 years? Well, suppose some of the argon is leaking out. They're checking the potassium compared to the argon. If the argon's leaking, you're going to get an old number just because it's leaked out. Hawaiian lava flow, 1801. When it erupted, they knew it erupted 1801. It was a historical observation. Gave a potassium argon date of 1.6 million years old. And they'll say, yeah, we know some of these dates we get are wrong. Okay, well then how do you know any of them you get are right? I mean, can you see how much fun a lawyer would have with this in a court of law? Your Honor, he's guessing. This would never hold up. Okay? Basalt from Mount Kilauea, however you say that. They pronounce every vowel over there in Hawaii. Kilauea, Kilauea-iki, something like that. However, since 1959, it erupted, gave a potassium argon age of 8.5 million years old. They know it's only 40. Mount Etna erupted again in 1964. New lava flow. Hey, let's check it again. Okay, 700,000 years old. Erupted again in 1972. Gave an age of 350,000 years old. New lava dome building inside Mount St. Helens. It erupted in 1980. New lava oozed up. People thought it might blow again, and then it quit. Ran out of pressure. They said, wow, brand new lava, let's go check it. How old is it? Well, they tested it several different ways. The whole rock, the feldspar, different ways they did it. Stephen Austin works at ICR, does a great job with this kind of thing. This is in the technical journal, Creation Ex Nihilo, technical journal. It gave ages from 0.35, that would be million years, so that's 350,000, to 2.8 million. This is from the same rock. I think they don't know. That'd be my guess on it, right? So same thing, potassium argon, you date a rock of known age, it doesn't work. If you date a rock of unknown age and no other way to check it, it works. It's ridiculous. And same things to consider for potassium argon dating. You don't know the decay rate, you don't know that it's not been contaminated, you don't know anything about it, basically. Okay, fresh dinosaur bones. Have they been found? I get people say about, oh, Hovind, you're lying, they never found any fresh dinosaur bones. Well, in the book, The Great Alaskan Dinosaur Adventure, published by Master Books, 800-999-3777. They've now changed their name to New Leaf Press, and Master Books is a part of New Leaf Press. This is in Arkansas. This book tells the whole story about how they collected unfossilized dinosaur bones. They had not fossilized yet in Alaska. Frozen bones. Some were petrified, some were lightweight. Journal of Science, December 24th, Christmas Eve, 1993, reported on the amazing preservation of the bones of a young duck-billed dinosaur found in Montana. Under a microscope, the fine structure of the bones was seen to have been preserved to such an extent that cell characteristics could be compared with cells of chicken bone. Finely preserved dinosaur bone. In northwestern Alaska, 1961, a geologist found a bed of dinosaur bones in unpermineralized. That means they weren't fossilized. How can the bone not fossilize in millions of years? A young Inuit Canadian Eskimo was working with scientists from Newfoundland's Memorial University, 1987, on Bylot Island. He found a part of a lower jaw of a duck-billed dinosaur. It too was in fresh condition. had not fossilized. This picture shows a dinosaur supposedly with a heart in it. It's rare for soft tissue to fossilize, okay, but it can. Usually only bones fossilize. Soft tissue can fossilize. This is from Time magazine for kids, this picture. April 27th of the year 2000. Scientists say they found a dinosaur heart. So then they went further and said, wow, it's a 4-chambered heart. How are you going to tell that? The thing's a rock, okay? They did x-rays and CAT scans and said it's 4-chambered. The argument has always been, if birds turn to dinosaurs, dinosaurs turn to birds. Most reptiles have a 3-chambered heart. All birds have a 4-chambered heart. Blood circulation is totally different in those two types of hearts, okay? On the human body, the blood comes into your heart from the body, which has used up all the oxygen. They call it blue blood, okay? Or it's not really blue, but it's bluer. Then it goes to a second chamber, which pumps it out to the lungs, gets oxygen, comes back into a third chamber to receive it from the lungs, puts it over to the fourth chamber, which pumps it back out to the body. So you have 4 parts to your heart. That's why you hear your heart beat, boom, 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 boom. That's the different valves opening and closing, moving the blood around. Okay, who cares? Reptiles have a 3-chambered heart, most of them. Birds have 4. With a 3-chambered heart, the blood comes in and it gets mixed, half of it from the lungs and half of it from the body. So it's always only half oxygenated, which is why reptiles are a little slow, when it gets cold. One of many reasons why they're a little slow when it gets cold. And they don't have the energy for long-distance, high-speed chases because they would run out of oxygen in their tissue. Whereas a mammal with greater oxygen in their blood has, different long-term endurance kind of stuff. Birds have to fly, which takes a lot of oxygen. They couldn't do it with a 3-chambered heart because that system simply wouldn't supply enough. Okay, next week we'll take up with some more questions and try to get as far as we can on our frequently asked questions section. So we'll see you then.